Hey, hi guys. Good morning. Hello everyone.
Good morning, Shiva.
Good morning. Good evening, Mamta. How are you? After a long,
Good afternoon here.
I didn't get you clearly, Mamta.
I said we are talking after 1 year.
Yeah, 1 year, even more than that.
I think it's 1 year, Shiva.
Oh, okay, okay.
I think last July we finished
Yes, yes, correct. Last July
because
we
July,
finished it. Okay.
yeah, was a long weekend. Then you finished. I still remember.
Yeah, okay. Um,
Are we doing any setup or anything on the system today? Are we checking?
no, Mamta, no need. So the agenda is like today. I will just introduce you to the Spark. So I will
Mm-hmm.
show some one or two examples, like
Okay.
so how easy it will be into Spark and how fast it will be in Spark. I will just show the differences between the Hadoop and Hadoop MapReduce, Hive, and Spark native code or Spark SQL. And
Okay.
I will just basically explain the basic features of Spark today, and
Mm-hmm.
then we'll start with Scala from tomorrow onwards.
Okay. And one more request, if you have any study material, just give it to me this weekend, is a long weekend for me. I'll try to brush up something.
Um, Again, sorry, I mean I didn't get you clearly.
Some PDF or some study
Oh,
material
okay,
which you
okay.
refer me. So if you give me, this is the long weekend for me, I can try to grab something.
Oh, okay. No problem. Sure, I will do that. I will share the Scala PDF.
Okay.
Okay.
Thank you.
Yeah. Okay. Yeah. So let me start sharing my screen. Um,
Mhm.
okay.
Hey Shiva, has it been long? Have you already started? This is Madhavi.
Hi, Madhavi. Just now starting.
Okay.
Yeah, just now we are getting started. Like, okay.
I think Shiva, we should introduce each other.
Yes, yes, yes. I will definitely do that. Okay. No worries. So let me first give you the agenda for today's session. First, we'll introduce ourselves before even going into the introduction to the Spark. Okay. And then after our introductions, we'll discuss the basic. So what is Spark and why we need to go for Spark, and differences between Spark and Hadoop, and any open questions related to your Hadoop, Spark in general, or any open questions related to the Spark course and Spark contents. We'll discuss the Spark contents, and I will leave it as an open discussion. Like anyone can suggest, like um, anything more needs to be added, or any flavors that you feel like. Okay, and the dependencies, the prerequisite for your course, both from your software skills and as well as hardware dependencies on your machine. So with that, we will wrap up today's session. And from tomorrow onwards, another 5 sessions we'll plan for Scala portions. First, we'll majorly concentrate on Scala programming language for initial 5 sessions at least. We'll discuss both the functional programming features and as well as the OOPS concepts of it. And then we will start with the Spark programming. Okay, because most of the times, I can say at least 60 to 70% of the scenarios, Scala is being used along with Spark instead of either Java or Python. Okay, so I don't say It's nowhere being used Python or Java. Yes, it's being used, but the most popular combination is the Scala for Spark. Okay.
Would you also be giving like at least some kind of introduction to Python, or would you limit it to just Scala?
I will give you basic examples, like 1-2 examples on Spark, Python as well. Okay.
Thank you.
Yep, sure. Yeah. So coming to my my introduction, most of you people might be knowing me already, either through the blog hadooptutorial.info, or yeah, as you know, some of have already attended my Hadoop training courses. Okay. So myself, I have almost like 8+ years of experience into IT, and out of which almost 4+ years into Hadoop and the big data domain. Okay. Almost like 2.5 years into 2 years to 2.5 years into Spark as well. So I completed my first project into Spark in the December of 2014 or so, or the early 2015 Feb or so. Okay. So prior to that, we were doing our POCs on that, and then launched our project in that. Okay.
Are you certified in Spark?
In Spark, no, I didn't do the certification. I recommend people to do that, but I don't do it.
How important is certification in Spark world?
Spark World certification, that time when we were entering into Spark, was only from Databricks, and that Databricks Spark certification included Spark Native, Spark SQL, Spark Streaming, and Spark Graphics, and Spark mlib also. Okay. So because of all these various components, and we mastered and we got chance only to work on, because here Spark is suitable for both data engineering and as well as data science portions, both of them. Okay. So coming to data engineering portion, most of our Hadoop developers role will end up into Spark native programming, and as well as Spark SQL and Spark streaming at max. Okay. Spark mlib, Spark R, or Spark graphics, these things will be mostly needed by the data scientists. Okay.
What if will you just show us Spark R as well? Is it possible? Do you have any idea?
Yes, I can show you the basic hello world examples into Spark Python, Spark R as well. Not an issue. I can show you, because we set it up Spark R. I first time set it up the Spark R also into our clients cluster. So as part of Spark 1.5.1 release. So it got recently integrated with Spark R in the last few months back. I can say like not more than 6 to 7 months.
How is this different from MapR?
MapR is different, Spark R is different. Like MapR is nothing but one another Hadoop distribution. Okay, same like your Apache Hadoop or Cloudera Hadoop or Hortonworks Hadoop.
Right.
Right. So MapR, you should not get. It is underlying the HDFS is also different for MapR. It is something like MapR FS. And its Mapreduce algorithm and all other Hive big remains the same there. The HDFS system will change. So there R stands for, it might be standing for the statistical, but not on Spark. Okay. This here Spark R is like the processing engine is Spark.
Okay.
Okay. So MapR is equivalent to, or you can be treated as one another commercial Hadoop distribution. It's not Spark.
Right.
Okay.
Right. So I only had an idea about MapR, not about SparkR. So I was thinking maybe SparkR is also another flavor of Spark, you know. That's right.
Another flavor of Spark in the sense, see, SparkR is something that enabling you to use the light fastening speed of Spark for R applications. You will do the same R coding, but in the backend, you will run it on Spark engine.
Okay.
We know that R can be integrated with Mapreduce R also, right? Mapreduce,
Right.
RMR,
Right.
RHDFS. These packages, if you install, so you can read in your HDFS files directly into R, and you can process your those files through Mapreduce processing engine. You will submit your R code, but that will get submitted as a Mapreduce jobs in the backend that will be submitted on to Yarn framework. Correct? Similarly, instead of Mapreduce engine, we'll use Spark engine with Spark R. That's it.
Okay. Thank you.
Shiva?
Yes.
The R is like Spark is supported R language. You mean to say that Spark R is that, or is it?
Yes, exactly. Exactly.
It's R language, right? It's
R
like
language. Correct.
yeah.
Correct. Yep. Okay. So before delaying anything, let's get introduced with each other, and then we'll discuss the basic features of Spark. Then we'll see what are all the languages are supported by each of them, and I will try to provide you at least one example. So my major concentration will be on Scala, but still I will provide you at least one example on each of the languages. Okay, so Python and R and even Java and Scala. Anyway, you will see lots and lots of examples. Okay. So these are my technical strengths. Yeah. So before jumping into the course contents, the Spark introduction, let me go through people in the list. Okay. Hey, hi Anand. Hello.
Hello, Siva.
How are you?
I'm doing good, man. Nice to reconnect back with you.
Oh, thank you. Okay. Yeah, I know many things about you, but I want you to introduce you to the new Spark team, Spark batch.
Hello, I'm Anand Ajmera. I just completed my Hadoop training with Siva. It was very nice, fun. And I'm eager to learn back Spark. I have a data warehousing and BI background. So I'm eager to meet you all guys.
Yeah, thank you, Anand. Okay, welcome back. Okay. Next in the same sequence, Gopinath.
Hi, Shiva.
Hi, Gopi.
Hi. Hi, all. This is Gopinath, having Java J2E technologies background, overall 8 years of experience.
Okay.
That's it.
Do you have any prior Hadoop knowledge?
I don't have any prior knowledge of Hadoop. I just have only the basic knowledge of Hadoop, like what is HDFS, just the theoretical knowledge. That's it.
Okay. Okay.
Where you guys are located?
I'm located in Hyderabad.
Okay.
Okay. Yeah, I need a few details from each one of you. Like, what is your technical background, and whether you have any knowledge or experience on Hadoop, and where are you from? Okay. And in the chat box, I want everyone to drop your active Gmail ID, especially Gmail ID. Okay, not Yahoo or not any other your company email IDs, because I will be sharing my PPTs or videos or calendar invitations, everything through Google. Okay, you will get the Google Calendar notifications, you will get the Google Drive file sharing notifications, and Gmail notifications. So I especially need your Gmail IDs and your WhatsApp active phone number. I will be giving you creating a WhatsApp group for this Spark batch. You will get notified through that WhatsApp group also. Any short notifications, or you can post any of your questions there, and we can discuss your questions among with the group. Okay. So for those two reasons, I need your active Gmail ID and active WhatsApp phone number. Okay. Yeah. Go ahead, Gopi. Sorry to interrupt you. Thing is, my recommendation for you is you should have at least basic knowledge on Hadoop. Meaning, so what is HDFS? What is Mapreduce? At least what is Hive? These things.
Yeah, I have these basic knowledge of these core components, Shiva.
Okay.
Is it fine to continue on Spark tutorial with you?
Yes, I need at least, like, say when I talk about HDFS file, when I say Hive table, when I say Mapreduce program mapper class, reducer class, or something, you should not get surprised. Okay. Yeah. So Hive, HDFS, Mapreduce, and a bit of base, a bit of what is HBase tables. You should have that understanding. Okay.
Okay. Do you have any orientation course on these ecosystems?
We have our Hadoop complete batch, full batch starting from the next Friday onwards. Okay.
Okay.
Yeah. Maybe that might be also of your interest. Like the thing is, I would recommend to start with Spark, but just with Spark, I don't see, like, it's just on one another add-on, like you can add it to your big data experience. You need a Hadoop as well. Okay.
Okay.
Yep. Let me start with Ankita Srivastav, right? Hey. Hi, Ankita.
Hi.
Yeah. We were discussing, like, I was just giving the introduction to them, and I was asking the same from everyone. So can you please give me your technical background? Where are you from? And whether you have any exposure to Hadoop or any other tools.
Yes, currently I'm working in Hadoop, and I have knowledge of Pick, Hive, Uzi, and I want to explore this Spark.
Yeah, good then. Okay. So where are you from?
I'm from Pune.
Pune. Okay. Yeah. Yeah, let's move on to Kalpana.
Yeah. Hi Shiva, this is Kalpana. I'm from US. I mean, I have total 5 years of IT experience in India. I recently moved to US. And now currently I'm looking for jobs in US. I mean, previously it was mainframe, so I just want to shift my technology.
Oh, okay.
Yeah.
Yeah.
I mean, I already have attended Hadoop training in Hyderabad.
Okay.
Yeah, but I just want to learn Spark as well.
Okay, no problem. Yes, that's great. Okay. Yeah, just adding your Spark experience. The thing, what happened is, in the trend, last year up to, I can say, till mid of last year, when we were looking for developers into Hadoop, we were just looking mainly around Hive, Pig, Impala or HBase, these things, and bit of Mapreduce was sufficient for us. So these days, from last 1 year or so, when we post our job descriptions, along with these Hadoop ecosystem tools, we also put Spark as mandatory. Because these days, Spark also become a tightly coupled component into the big data ecosystem tools. Okay.
Yeah. Also, I'm getting calls. They're asking mainly Spark, so I just want to learn that one.
So with this, in open source community, fast changing world, we have to adapt the new coming tools. So yeah, it's good to learn the Spark as well, and then apply for the Hadoop or big data developer roles. Okay.
Yeah. Okay. Yeah. So one more thing, Shiva, are you going to provide any real-time projects?
Yes.
So that would be helpful.
I will explain. I will explain the real-time end-to-end projects. Okay.
Okay. Thank you so much.
Yep. Thank you. Okay. Next, Madhavi. Yeah, just get introduced to the team. I got your background. Lots of so much of struggles and twists and turns technically.
Is there another Madhavi? Are you talking about me, Shiva?
Yeah, about you only, Madhavi.
I did. I have a knowledge of Hadoop. Plenty of theoretical knowledge, no practical knowledge at all.
Okay.
But about 1.5 years worth of theoretical knowledge, I would say. So I guess I follow your blog actively every time I'm in between projects. I'm currently in between projects, and I thought of getting in touch with you so I could actually try to gain some practical knowledge in Hadoop.
Spark. Sure, Madhavi.
I have no knowledge of Spark, so.
Okay, I will make you comfortable in both in Spark and Hadoop as well. Okay, no worries. And I mean, what was the biggest challenge that you faced? I mean, did you ever try attending the interviews, or you didn't even try attending the interview?
See, the type of person I am, I cannot lie very easily. So, I mean, what happens in the interviews is they ask me simple questions. Like, when they ask me questions theoretically, I'm able to answer.
Mm-hmm.
But they ask you, what do you do on your day-to-day jobs? How do you deal with this, or something like that? Of course, looking at my resume, they would expect me to have practical knowledge because I've been working since the past 12 years, 13 years. So,
okay.
And me not having practical experience in this really didn't help me much. And I would just kind of go blank, I guess, because I really don't know what would happen on a day-to-day basis.
Then you should have called someone who is working on Hadoop and get to know these things, right? You could have called me 1.5 years back itself. You would have saved a lot of time.
Yes, I would have. See, that is the thing. Hindsight is always 20/20. So
Okay.
I did call, but I called the wrong persons, I think.
Okay.
What can I say? I did attend a couple of different different institutes training.
Okay.
But it didn't do me any good. I actually had to explore myself on the internet. I prepared my own notes, and I got certified, Cloudera certification as well.
Okay.
But what I lack is practical knowledge.
No worries, Madhavi. I mean, I can guarantee you that whatever you need for your interviews or your real-time experience, I will provide you that. Okay.
And also, most of my knowledge is from me trying to gain from the internet whatever I could learn. So if I ask you some really silly questions, please do bear with me.
No worries, Madhavi. I have been through this kind of question. So many batches. Okay, no worries. I mean, if you refer my one of few old batch videos, even you may get frustrated sometime, but I never shown anything on anyone. Okay, don't worry.
Thank you.
Okay.
I have one quick question. In your technical strengths, is Storm something that is part of this Spark thing, or do you explain something about Storm as well?
No, we'll not be discussing the Storm. We'll be covering the Spark streaming, which is the equivalent one and which is the upcoming one. Storm is getting obsolete.
Okay.
The way, I mean, by the time you came to know about it and by the time you start learning it, some of the tools are getting vanished and the newer tools are coming in that place.
True.
Okay. Yep.
Thanks.
Yeah. Thanks, Manvi. Then, yeah, Mamta, how is your journey going on from last 1 year?
Hi Shiva, my journey not much with Hadoop though, because I'm working on many technologies, but this one I just wanted to upgrade myself. You never know where I'm going to use it.
I mean, I think most of your batch guys got already working, right? I mean, you remember Sanat Patel? You remember?
Yeah, I know most of them. Everybody, in excluding me, because I'm already working in a good bank, and it is one of the big banks in Canada, and I have my family life, right? So, and the travel, everything, I have to look for it. But more than that, now you never know when the bank, they scale up the projects, and I'm also thinking, like, after working so many years in the same company, to look for something new. And SQL 2016, they are already giving big data support. I do a lot of all these SQL, Oracle, .NET, and MEC. So I thought it is some other way it is going to be useful. So I don't know whether I get into this Hadoop or not, but I just want to upgrade myself.
Yeah, I mean, I'm a bit surprised that you're still not working in Hadoop, because all your batchmates, in my knowledge, Pranav, Hiren, and all his friends, everyone.
I know only this, right? And I feel, because I basically work on many technologies, not one. Like SQL, Oracle, .NET, and even in the .NET, all flavors, all part of it. And yes, SSRS. If I go to Hadoop, I believe it's Hadoop is, I don't know, correct me if I'm wrong. It's like same like ETL tools. We were using SSIS, SSRS.
Yes.
Upload, do something, process it, and show us some reports.
Correct.
And like here, that is only one portion for us. In my experience, that is only one of the portions, not everything. And so in the day-to-day, in the banking, the real-time application, I see much more challenges than Hadoop. So I feel if I go to Hadoop, I will be only on one side of and the data. I miss the other side. And all these years I was been working, you know, it's kind of, my strength is different from what I see, but I just wanted to explore this time. Okay. Yeah, no problem then. Yeah, I think then you intentionally didn't move on to Hadoop then, right? No. Because see, the bank which I'm working is one of the top 3 banks in Canada, and every month almost I used to go to Chicago for my business trip, and it's there is no point in moving. Those guys who joined with me, they didn't have a job, or they didn't have experience. Yes, I do agree that. Okay. Yeah, I got your point, Mamta. Thank you. Hi, Praninder. So, hello. Hello, Praninder. Can you hear me? I think some audio issue from his side. So I can hear you. I think some microphone issue might be from your end.
Okay, just leave me your WhatsApp number and active Gmail ID. I will talk to you later. Okay. At least if you are facing any audio issues right now. Okay. So try joining through phone as well. Yeah, you can join through the phone as well. I think that is. You can join through your laptop to see the screen sharing, and audio you can join through phone as well. Okay. And the dial-in numbers, I think they are toll-free only. Okay. And yeah, next, hi Purushottam. Hello.
Yeah, hi Shiva.
Yeah, hi.
Yeah, good morning. Myself Purushottam.
Yes.
Yeah.
Your background and where are you from?
Yeah, I'm from Bangalore. I have overall 8+ years of experience in different technologies, like initially Java. After that, I did 3 years PLM, Product Lifecycle Management. After 1.5 years, I'm working with Hadoop. Like not much. We did POCs, and we are working Woozy, Scoop, Hive, HDFS. But Mapreduce and all, I don't have much experience. But I have theoretical experience in Mapreduce. But
Okay.
real time,
yeah, these days Mapreduce is getting, I can say almost like obsolete or not much using.
Okay, yeah. I follow your blogs regularly, so it's very nice. That's why I will get into join.
Oh, that's great. Thank you. Okay. Yeah. Hi, Subramanian.
Hi, Siva.
Yeah.
Thank you very much for your session today. I'm following your blog. It's really excellent. And you are doing wonderful service through your blog. And I live in New Jersey, and I've got around 18 years of experience in IT industry. For the last 12 years, 8 years, I've been in US, and I've been working in testing, test automation for the last 12 years.
Okay.
For the last 1.5 years, I've been moving into Hadoop. I've been attending trainings and practicing some projects in offline, but I'm yet to start my career in Hadoop technologies. As some of us discussed earlier, I just need to put my resume appropriately so that I'll be receiving any calls for the interview. That's one thing. Also, I just want to know how to later on how to update my resume to reflect some projects kind of convincing way, so that I should also be able to discuss about that at the time of interview too. I just need your help on that later on.
Sure, Subramanian, Subbu. So what I can do is first I will share some of videos that I have explained to the recent batch just 10 days back. Okay. I have explained 2 to 3 real-time projects end to end. I will share those 2 videos with you first. Just go through them. And did you get chance to go through all the 3 videos that I shared with you already? Like a Flume, Scoop or something you asked, right?
Yeah, I saw that. I reviewed it.
Okay.
I think you gave me source codes plus video also you gave me. I went through the source codes.
Okay. Yeah. So just go through these project descriptions also. After that, we can have a discussion sometime around any weekend. And I will go through your resume as well.
Okay. Then, now I'm practicing Scala also. Scala with streaming.
Okay.
Spark streaming too, and I'm able to capture the Twitter. I think I spoke with you earlier. I think.
Yes.
I'm able to capture the tweets, and I'm able to save it in the Cassandra DB. And I'm using R right now for doing generating some analytical reports.
Okay.
Later on, I just want to understand from you how significant Spark R is. How we can replace Scala plus R using a Spark R directly.
Spark R, I can say I myself am a beginner to that. I'm not that much an expert in that. So because we do, I'm part of data engineering teams. Data scientist team in the same company, I have many data scientists who work on Spark. Or any additional help, if I can't do that, I will get it done with my friends. Okay.
Okay. I'm good at R also.
Oh, okay, that's great. Okay.
Thank you.
That's good. These days it is the upcoming and the hot things in data science.
Yeah, we should know both data processing plus data reporting. Both we need. Yeah.
Hi, Hussein. Hello.
Hey, can you hear me?
Yes, Hussein.
Yeah, okay. Yeah, I'm based out of US. I do have Hadoop experience. I'm currently working in the Hadoop domain. I have experience with HDFS, Yarn, Hive, Ambari, a little bit of Scoop and Uzi, and also Kerberos and authentication for Hadoop cluster. So that's what I have experience with, but I'm looking to get more experience in Spark, Scala, Python. So that's why attending this session.
Okay. Yeah, that's great. Then you already have a real-time experience. Okay, so yeah, majority of you, or I can say all of you, have a basic knowledge on Hadoop, and some people are real-time working experience as well. That's great. And some people having this basic theoretical knowledge and basic hands-on, like at least I can say basic HDFS commands and Hive create stable and select queries. I hope you are up to that level, at least comfortable with it. Okay, then we are good to get started.
Hello Shiva, this is Praninder.
Yeah, Praninder. Yeah.
So yeah, I think there was some problem with my microphone on the PC. But yeah, so I'm from Chicago. I've graduated recently. I've done my master's in computer science.
Okay.
And I have like 2 years of experience on Hadoop and AWS platform. So I'm kind of like good. I'm like so right now I'm working with Ford as a Hadoop specialist. And so yeah, I do like basic analytics using Hive Pig and a few other Hadoop ecosystem tools. And I'm basically into mapper distribution of Hadoop and also Cloudera.
Oh, so okay.
I would like to. So yeah, now I would like to learn like a real-time streaming on HDFS using Spark, like Storm. But yeah, like so that's the reason why.
Okay.
I don't have like a lot of hands-on experience on Spark, so I want to learn Spark.
Yeah, that's great, Pranin, that you already have a 2 years experience into Hadoop. Yes, we'll go through all these things like Spark Native and Spark SQL and Spark Streaming as well. You will see the different types of streaming in streaming net also into the Hadoop. Okay, so I will show you some real use cases as well also into that.
Okay, thank you.
Okay, thank you. Yeah, so let's get started. So I don't need to give the basic introduction into what is big data and what and all these things. So I got to know that almost everyone knows all these terms and all. Okay. So coming to this, how Spark got evolved, the history behind its evolution. So just before even the Hadoop got introduced, came into the market. So the first time when our enterprise organizations were not able to solve the large data or huge data, so they came up with the first level of distributed systems. When you can't store and process the data in one single machine or server, they maintained a distributed fashion processing. And that first level of distributed systems that came into the IT industry, or like some of the RDBMSs like Teradata and Netezza, and this Teradata can process up to terabytes of information, and Netezza is also from IBM which is a special separate box coming with hardware box coming with the software installed on it. These are also on the same notion of distributed systems, but they are scalable up to certain limits. Beyond that, they are like not able to scale. So that's the main problem. And second one is they are proprietary and they charge lots and lots of millions of dollars for annual renewals. Okay. And second generation distributed systems are like, if you talk about the Hadoop and NoSQL databases, we can consider into that. So these are open source, so cost saving. They can run on commodity hardware also. And they can scale up to some terabytes, even petabytes as well. But the problem is they are mainly batch oriented, and the latency is relatively high. The response time is relatively high. That is why we always start avoiding Mapreduce because of its slow responsiveness. And coming to third generation distributed systems to avoid this performance issues. So we have one of them is like Spark, and there are few other tools which are in incubating status, Apache Flink or a few other Apache Ignite, and these things, they all get the fast speed just because of exploiting the RAM memory, the main memory of your servers as much as possible. Like instead of reading the files from the disk, from the hard disk directly, they load entire data into RAM memory, and from there onwards it starts reading that. So relatively, reading anything from main memory or RAM memory is much faster than reading from the HDFS disk, or reading from your hard disk, or reading from your HDFS storage. HDFS storage is nothing but the disk storage only, because that gets distributed onto all the different data nodes. So,
Shiva, can I interrupt you? Like, can I ask you a question?
Yes.
Now or like?
No problem. Yep.
So when we are like talking about second generation and third generation computers, the reason why we moved to second generation computers is like the first thing is like cost, right?
Yes.
Because of NetEase appliances, they are like really expensive.
And second one is scalability.
Scalability, right?
Yep.
So when we are like talking about third generation distributed systems, then we are again like bringing the concept of high memory, right?
Correct.
So again, they eliminate the concept of commodity hardware, right? So
yeah.
I mean,
commodity
you have to like
commodity hardware in second generation. It's just a theoretical point. In my opinion, it's no longer a feature for Hadoop or something. You can run it, but how much value you will get when you run it on a commodity hardware? Even if you see the Cloudera or Hortonworks, the typical the data node configurations they suggest you is minimum 256 GB RAMs and at least 24 core CPUs, multi-threaded CPUs, and 100 Mbps IO channels, and at least 10 to 12 TB hard disks to type to them. They are not commodity hardwares anymore. They are like a huge servers only. Of course, I mean, if that is the question, like you can use the same commodity hardware for Spark as well. Here, how much ever the RAM memory you will get here, the same RAM memory will get used by this, but you will get only up to a limited speed.
So it's like a trade-off between the memory and
Correct.
the processing, right?
Correct. So, so day by day in the market or in the industry, so RAM is not that much costlier in the early or the pre-2000 years. Okay. So these days RAM is getting cheaper. So that's why trying to exploit that as much as possible. That is the notion. So obviously, when you are dealing with GBs and terabytes of information, reading it from the disk slows down your performance. So the next option, the only option is reading it from the RAM. So based on that concept only, all these tools came up, like, so Spark you can see, and Apache Flink is there, and Apache Ignite is there. So all these things, their main concept or the main funda behind these tools are like loading the data into RAM. That is how they achieve the speeds. Okay, it's just a trade-off, correct? So if you need speed, you need to go for high RAM memories. Okay.
Shiva?
Yes.
What is the industry standard, suppose, when you say that, you know, like what is the industry standard for RAM? You can say that it's like scalable, right? You can have a number of units connected. And so what is the standard approximately? Like, is it 8 GB or 16 GB or something should be there, right?
Yeah, the industry standard. Yeah, industry standard is 256 GB RAM machines. Okay.
Okay.
256 GB. I mean, even whether you are using Spark or not, still the Cloudera's standard recommendation, or even from the Hardenworks, the standard hardware recommendation from both of these things, if you refer any of the documentation sites also, because we do involve into the Cloudera meetings most of the times. Their strong recommendations is to use at least 24 GB, 256 GB RAMs and 24 core CPUs, multi-threaded CPUs.
For our system or only for a couple of it? There might be a number of...
No, n number of machines, it's the same.
Okay, thank you.
Okay.
Thank you, Shiva.
Yep. So hardware is dependent on our requirements. So we can decide how much memory, how much storage capacity that we need. Generally, we go from around 8 to 20 TB or 22 TB ranges of storage hard disk capacity for this CPU and RAM configurations combination. This is the most standard the hardware. Even if you see a small enterprise organization which is planning a 10 node cluster, even with that, if you see the real-time configuration, you'll find these figures, not less than these. So I worked on Hadoop clusters. So when it was around like 64 GB RAM for data nodes and 128 GB RAM for master machines. For one of our clients 3 years back, almost like it was, the cluster was built around 2011 or so. So that time itself, this 64 GB RAMs and 128 GB RAMs they planned. So these days, from last 1-2 years, even if you have a 10 node cluster on your client, so that will be at least with this configuration. Okay.
What is the RAM on the master node for this? So it's the same.
It's the same. It's the same. No, here these days we don't need, since anyway data nodes also, like we are giving so much of RAM memory, so that much RAM memory is sufficient for your master as well.
So because most of the work is done on the node, right?
Master node is like a kind of indexing stuff. So this 256 GB RAM is sufficient for them.
Okay.
It's more than enough, I can say. Okay. Yeah, sometime, I mean, when we get into any discussions, we can talk about like how does these resource allocations will happen. Anyway, this is not a job of your developer role or something. It's purely an admins and infrastructure team's responsibility to distribute the resources, the cluster resources on each of the your Hadoop ecosystem tools, including Yarn, Spark, or Hive, Impala, or whatever. We can discuss sometime later when it comes in. But this is not hard stopping, okay? Yeah. So with these third generation distributed systems, so they started using the RAM memory as much as possible, and they can work on multiple core systems on the same machine, and they can very well integrate with the HDFS for storage purposes, and they can run on any of the distribution processing frameworks. It could be either Apache Mesos or Yarn, and in real time you will see mostly 99% of the cases it's Yarn only. It's Yarn integrated because so Hadoop got evolved first. In any enterprise, Hadoop cluster might already be set up. On top of that, they plan to upgrade their clusters to Spark as well. Then obviously the option they will go with is Yarn only, because they already have a HDFS, Yarn, and Hive, Pig, everything set up. So on top of Yarn, they will go for Spark to the resource management of your Spark. Okay, we'll discuss a lot about that, Spark with Yarn integration. Okay, so now coming to the Spark. So what is it, and how is it similar to your Hadoop ecosystem tools, whatever so far you know? So we'll discuss them. Okay, so Apache Spark is something similar to your Hadoop. It is also an open source, and it is also a parallel data processing framework. But the difference is it uses in-memory cluster computing, which can access faster than disk access. That's the only difference. And Spark is fast, and it's like a Mapreduce, like a processing engine. It's also one of the processing framework or processing engine you can call. It improves efficiency when compared to other processing algorithms like Mapreduce, mainly in-memory computing primitives and any other general computations or computation graphs as well. So Spark first time initially started at AMP Labs, which is now changed to Databricks company. So few guys from AMP Labs came out and they started the Databricks. That is from where the Spark got released, the initial releases from Spark. It is not from Hortonworks, it is not from Cloudera. So sometimes people will get confused that since Cloudera is giving or something. So the way your HDFS, Mapreduce, Pig, and HBase, all these things came from Yahoo, right? They got first time initially released from Yahoo, and they got contributed to ASF, Apache Software Foundation, open source community. From there onwards, everyone took them and they built their own flavors. It could be either Cloudera, it could be IBM Big Insights, it could be Hortonworks or whatever. Similarly, Spark came from Databricks. From there, it got contributed to ASF, Apache Software Foundation. From there, everyone took and got merged into their Hadoop distributions. their own version of distributions, I can say. Okay, so it's coming to its history. It started as a research project at the UC Berkeley AMP Labs in around 2009. And first time it was open sourced in early 2010. And then after being released, Spark grew a developer community on GitHub. So it was released on GitHub and entered into Apache ASF around 2013. So Apache became a top level project only in the early 2014. So that's where once any tool becomes top level project, then only it is recommended to start using that for your real-time uses. Okay, so until then, if it is in alpha or beta releases or incubating phases, it's never suggested to, it's not recommended to use it for. You can do some POCs, up to POC is fine, but using it for real use cases, no one guarantees if something goes down. Okay, you'll not get any enterprise support as well. Okay, so I can say at least from starting from the mid of 2014, people started or enterprises started using Spark. Okay, almost like 2 years now. So at present, major contribution to Spark is from Databricks, and the code base size in Spark is just 20,000 lines of code. So when it was around 1.2 or 1.3 releases of Spark. This is just purely because of Spark is written in Scala. And Scala is so concise, you don't need that many lots and lots of lines of code. In Hadoop, just 1.0 release itself is having so almost 90,000 lines of code. It was written in Java. It is, okay? So when we are looking for Spark, at least we need to answer a few questions why we are going for Spark. So when we are choosing any processing framework, so we consider few things. So whether it is speed enough to process my use cases. So here for Spark, Spark can run up to 100 times faster than your Hadoop Mapreduce in some cases. So this is the ideal numbers given by the Databricks, but at least you can see in real time, you can see at least 60 to 70 times faster minimum. Okay, most of the times you can see at least 60 to 70 times faster. May not be up to 100 times in your real-time clusters, because this depends on, I mean, this is same like when any motorcycle manufacturers, they are selling their products, they say it like their bikes give you 100 kmpl, but in reality, comes into reality, it might give around 60 or 70, right? The same way, under ideal configurations, it can give up to that speed, but depending on your real-time, your Hadoop cluster configuration by your administrators, they might have some trade-offs. They might be allocating some more RAM memory for other resources than Spark or something. So based on all these factors considering, your Spark is still relatively very faster, and you can still get up to 60 to 70 times faster than your Mapreduce results. Okay, and it's ease of.
I have one quick question. So in case if you reduce the memory or increase the memory, to affect, because it's everything. I know it is reading from the RAM. By reducing or increasing the memory, does it has any effect?
Of course, yes.
I mean, you mean to say that if you increase the memory, it can be still faster,
yes.
But it can go up to a certain level, right? Even though if you increase the level.
Correct. See, increasing the RAM memory, I mean, will solve your large files processing. If you are processing really GBs and GBs or terabytes of information of data, if you are using that into RAM memory, that time it requires even more large fuse memory, right? RAM memory. So that time, obviously, it will improve the speed. Otherwise, it will read chunks and chunks of data into RAM memory. It will load chunks of data into RAM memory, and from there, it will process that.
You mean to say that indirectly we are depending on speed is depending on the RAM, right?
Yes, indirectly, speed is depending on the RAM.
Okay. Okay, thank you.
Okay, we'll go to those internals, how it gets loaded into RAM, and how it the trade-off works. Like, so these things internals will discuss once we start our actual Spark hands-on or Spark sessions. Okay, this is just a overview for you. Okay, so it's ease of use. The second feature you can say about it. It can be used with many programming languages, like either Java programming language, a Scala language, or if you are good at Python, you can use Python as well. As we saw, some resources are good at Python and some are good at R. You can use all these languages and you can leverage the Spark speed. Okay.
Sorry, I have a quick question. When we use the other languages, like I do R, Python, or Java, like if you see Hive or Pig, indirectly it is going to convert as Mapreduce program. In this scenario, is it going to convert it as Scala, or at the back end, what exactly happens?
It will not get converted into Scala. It will run that as it is into the Spark core.
Independently.
They have their own APIs available. The Spark, I can say Spark stages and tasks will be there. So into them, they will get converted.
Okay, so it doesn't use any intermediary language, right?
Yes.
Does it
it is not an intermediate language. That is a framework. It will get converted into maps and produce tasks, right? I mean, it's fine. Yarn child. So here also they will run under Yarn chails only. They will run as a Spark stages and Spark tasks.
Okay, thank you.
Okay. And one more thing is like, so I want to take a pass after each topic, not instead of each point or something, because it breaks my flow. Okay.
Okay.
Yeah. So I will give you a pass, or like I will give you a break after completion. Let's say if I'm talking about this topic, so there are 5 or 6 points around it. Okay. So if I complete all these things, then I can open for your questions. Thing is, I might forget the sequence or things that coming in mind.
Okay, got it. Thanks, Shiva.
Okay. So the next thing is the next feature or the next recommendation why we can go for Spark is its generality, all things in one place. It in one marketplace you can find almost all the processing tools. Like it gives you a stack of libraries. You can write your native Mapreduce code with your Spark native programming. You can run your Hive queries or Impala queries using Spark SQL. You can leverage your Apache's Storm using the Spark streaming and Apache Mahout machine learning features with Spark mlib. And if you want to plot any graphs, you can use the graphics. So you can combine all these libraries seamlessly in the same application. So if you set up Spark, you can use all these sub-components of your Spark ecosystem. You're getting all these places, same like your Hadoop ecosystem. Inside the Spark ecosystem, you can see all these components. So what I'm trying to say is you have a very good tight integration with all these tools, and you can leverage these things. And next thing is, yeah, it can run anywhere, meaning it can run on your local file system, something you have any files on your local disk. Yes, it can process that. If you have your data on your Hadoop HDFS file system, yes, it can read from there. Or if you have on even in cloud or something, your S3 buckets, even from S3 buckets also it can read the data and process. And inside the NoSQL databases also, it can read it from HBase. And for Cassandra also, it has some connectors to read the data from. Okay. And yeah, so it can read from various places. It can read it from your local disk. It can read it from HDFS. It can read from your NoSQL HBase or any other NoSQLs like Cassandra as well. Okay. And so this is reading your data from different locations and processing that data under different distribution processing frameworks. So Yarn is one such distribution from framework, and Mesos is another framework. Either you can run on either of these two frameworks, or you can even run your Spark in a standalone mode. Okay. So even though whether you get it or not at this point of time about Yarn, Mesos, and standalone. So at least for now, just make it as an index that you can run in different distribution processing frameworks. Okay. So there is a lot to discuss on about these points. We'll discuss many more things on once we start with our Spark architecture sessions. Okay. So for now, treat it like you can run under different distribution frameworks. Okay. And Spark gives you the advanced serialization mechanisms that can be used with it. Meaning in Hadoop, we use the Mapreduce serialization techniques, like it could be either your writables or through the sequence files or any compressed files or optimized files like ORC or something. So there it is more of like similar to Java kind of serialization. It is not that faster. In Spark, it uses the cryo serialization. So serialization is nothing but converting your data into a binary format, storing that data in binary format. And why do we need serialization is, so if you have to transfer data between one node to another node, obviously the data should be in binary format. This is not the limitation of your Spark, not the limitation of Hadoop. It is there from your computer networks concepts itself. In any network, if you have to transfer data from one machine to another machine, that should be in binary format, meaning that should be in serialized format. So for this serializations, in pure Java applications, Java serialization will be used, and in Hadoop MapReduce applications, we use those writables, int writable or double writable, long writable, those things. And those will be used for serializing your data into binary format. And here in Spark, we do have two types of serializations. Either you can use the default Java serialization, or you can go for the advanced cryo serialization, which improves your speed, your data transfer between your nodes even more faster. Okay, so to summarize its features, it is much faster, and it provides you multi-language support. You can use Java, you can use Scala, you can use Python, you can use R, and all the tools come at one place. Like you can write your Mapreduce programs, or you can write your logic in Spark native. You can write your Hive queries in Spark SQL. You can write your Apache Mahogany machine learning algorithms in mlib. You can plot your graphs with GraphX, and streaming data processing, Apache Storm or something can be replaced with Spark Streaming. So all these things. And it can read it. It can directly read files from your LFS, HDFS, HBase, or Cassandra or anything. And it can run on different distribution frameworks, Yarn, Mesos, or even the Spark standalone cluster. And it provides the various types of serialization mechanisms to even more speed up your processing. Okay, so the Spark has connectivity with the Cassandra, Hadoop, and HBase, all these things. In our course contents, I will show you all the real-time examples. For Spark connecting with HDFS, obviously it will be there. So with the HBase and with Hive, we'll see a lot. Okay. On Mesos, yes, Anand. Let me complete this slide. Okay.
Okay.
Yeah, let me complete this slide. So our main focus or real-time integrations in our courses will be like Spark with HDFS and Spark with Hive and Spark with HBase and Spark on top of Yarn. Okay, so these will be the combinations that we'll most frequently see in our examples during our Spark applications. Okay. Yeah. You have Cassandra connector also for Spark. Maybe I can point you to that in case if in your enterprises anywhere Cassandra is being used to that. And if you guys don't have Cassandra knowledge at all, then I can point you to some of the articles in our blog so that you can get a Cassandra knowledge. But others, whoever attended our Hadoop trainings and all those things, they are pretty much comfortable with Apache HBase as well. You can see how the same Java API that we have seen in Apache HBase that can be leveraged from the Spark APIs, or what are the equivalent APIs in Spark for Apache HBase. Okay. Yes, Anand and Mamta.
Shiva.
Yes, Anand.
We learn Impala, we learn all these tools, right?
Correct.
Where does this fall exactly? Because you know, if I use Impala, I get the same things what I achieved from Spark, correct?
From Impala, yes, it's the same thing. See, it is the same thing. See, like whatever you can run with your Mapreduce programming, you can achieve it through Spark native programming. Whatever you can run inside your Hive queries or whatever you can run from Impala shells, the same things can be run from your Spark SQL. Functionality is same. The speed differs.
So this will be still the fastest so far.
Yep.
Than what we have.
Yep. So in your quick start VMs, it might not be the same in case of Impala because the quick start VMs come with your Impala more preferences. You can see the default whenever you see the Cloudera's Hadoop installations or setup default configurations, they will try to give as much RAM memory allocated as possible for Impala mainly than any other tools, because they try to market that than any other tools. It's not an open source Impala. But whereas your Spark is open source, it can be used with your Hortonworks also. Whereas your Impala cannot be used with your Hortonworks.
But what I'm getting so far is like Spark is one place to shop, right? I mean, one place to go.
Correct.
You'll find everything in Spark.
Yep.
You will not have to use it. Okay.
Correct.
And the speed is the fastest.
Speed is the fastest. Yep. And the default, the default Hadoop cluster distributions. So the default, I mean, whenever we go for enterprise support from Cloudera, they will be installing our Hadoop and Spark, all those things into our clusters generally, okay, in your enterprises. The default configurations, it will be more, they will try to allocate more RAM memory for Impala mainly. So even than Spark, but in real cases, like when you need to actually leverage your Spark speed even faster than your Impala or something. So there will be again trade-off, like you need to allocate, you have to reduce some for other services, and you have to increase your RAM memory for your yarn mainly.
Okay. And then lastly, quickly, so if I have Spark, or if I am using Spark, I don't need to go into the Cloudera world at all, right? I mean, I can pretty much do everything from Spark.
Yes. Again, when you are going for Spark, you still need the HDFS, you still need the HBase or these things, right? Where will you store the data?
No, but I mean, that will be all done. I don't have to access the Cloudera command prompts and that stuff, right? I can do everything pretty much from the Spark front end.
Correct. I mean, I'm trying to ask you that. So you have, this is a processing engine. Apache Spark is a processing engine. This is also a processing frameworks, right? So where does the underlying data get stored?
So that will be in HDFS, correct? That will be in HDFS.
HDFS or HBase in real time, right? So if that is the case, again, you should go for either Hortonworks or Apache Hadoop or Cloudera Hadoop, right?
Right.
Okay, so that's why people sometimes will be under impression that it's a competitor. Spark is a competitor for Hadoop. Once the Spark comes, Hadoop will no longer be there. Okay, so that's a myth. It's not like that. It's one another add-on tool to your Hadoop ecosystem. Okay, your big data processing tools. It will never replace your entire Hadoop. It can replace at max Mapreduce. That's it. And Hive also, I can say it cannot remove or it cannot replace Hive. Thing is, it still uses the same Hive metastore. If you create any tables, if you do anything, the same way your Impala runs on top of the same Hive metastore, here also Spark SQL is just one another add-on or a layer on top of your Hive metastore. Okay.
So essentially, Impala then, sort of, right?
Correct. A sort of Impala only, correct. You can say. Yep. Yeah. And to be even more frank or to be practical, more practical on the Spark SQL, this is not even as much rich features or rich commands as Impala also, I can say, because Spark SQL got introduced from Spark 1.0 release onwards only, from last 1 year or 1.5 years itself. And Spark streaming came into existence into Spark from last 1.3 release onwards as well. Meaning from last 8 months or 9 months back. Prior to that, there was just some incubation stages were there. So, I mean, these are their ages, or I can say this period that when they got released. Okay. So that is the scope. Since this is, and you can say, I can say like Spark developer community is the largest open source developer community at this moment. So that's the future scope, that Spark is going to be very rich set of features and very well get matured and very well get reliable and robust going forward. As of now, at this point of time, we ourselves see that from every release to release, there are lots and lots of APIs getting changed, and we'll follow the latest APIs only. So I started my trainings from 1.3 onwards, Spark 1.3. I gave my first trainings on Spark 1.3, later 1.5, 1.5.1, and 1.6. So we'll start with the latest Spark release. Our previous batch went with Spark 1.6.1, I think. So whatever, if there is any another release came out in this month or so, we'll use that latest. We'll use this latest APIs only.
Shiva.
Yes, Mamta.
When they say it's only, it is in a way, it is going to replace the Mapreduce, right?
Yes.
How about, see, basically in Hadoop in general, I'm not talking about the particular thing, like we read, process, and output to something, right? So where do we read means like in Hadoop, like we use Flume or Scoop to get the data either from the log files or from database, right?
Yes.
So, and then we process with Hive or Pig, then you give it to some reports or something, or to store it in the database. Like, so here, do we still use those things, Spark and Flume, to read the data, or do we have something else here?
That is the ingestion part, right? So that is to get the data into HDFS. That ingestion portion can still be there.
Okay, so that will be still.
Yeah, that can still be there. And equivalent to Flume, the data ingestion, the streaming ingestion part we'll learn as part of this course, like Kafka. Using Kafka, you can collect the streaming data.
Okay. Kafka can be used here.
Yeah. And you can use Flume also, not an issue. You can use Flume. Anything, any ingestion tool is independent of your Spark. That is just to get the data onto your HDFS. And your Spark can run on any data that is present on HDFS, right?
Yeah. So, and the processing, we don't see when after getting the HDFS, like we were processing using Hive or Pig, and here it's completely with Spark, you meant to say? I mean,
yes. Correct.
Okay, so we don't use either Hive or Pig things, right?
No. Hive, see, we use Hive through Spark SQL.
Okay. So what, I'm sorry, like I don't have much idea, like what is that Hive and what is the Spark SQL? Like
Hive is nothing but running, maintaining your databases and data warehouses and tables and running your SQL commands, right?
Yeah.
Same features, you can run it through Spark SQL.
So which is more advanced and the robust? What is more, valuable at this time?
At this point of time, I can definitely say that Spark SQL is more advanced and more faster than your Hive. We'll see one example in this session itself. Okay. So yeah, this is how like the Spark API can read in from the storage systems, and it can run on any cluster computing mechanisms. It could be the Spark standalone cluster or Yarn cluster or Mesos cluster. Okay, and these are the Hadoop, these are the Spark ecosystem tools. So mainly the Spark core, and Spark core can be, we can interact with Spark core either through Java API or through Scala API or through Python or the R language. And on top of this Spark core APIs, so we have Spark Data Frames API, which is mainly for Spark SQL. Spark Data Frame API is purely for Spark SQL to leverage your SQL skills using the Spark engine. Okay, and this portion is called as a Spark core component. On top of it, the additional ecosystem tools or submodules, you can see it like Spark SQL to try with your SQL skills, and Spark streaming to process the streaming data that is coming, the live streaming data into it, and machine learning to apply some machine learning algorithms on the huge data by loading them into RAM memory and processing them. And graphics is one another ecosystem tool or component on Spark ecosystem to plot some graphs using that. And Tachyon is it is another incubating file system, I can say, similar to HDFS. It's an incubating tool project where it will be a bit faster than HDFS. Okay, but it's not yet. We did a POC on it almost like a year back, but we didn't start using it in real time because we don't have enterprise support on this from Cloudera. Okay, and this is the entire Spark ecosystem, and it can be run on in either of these distribution modes, distribution frameworks. Okay, so a few points about these things are like using Spark with Hadoop, use Hadoop as a storage, both for input and as well as output from Spark, and Spark program run as a yarn jobs by using the resource manager component of your yarn to manage your tasks and stages. And the core engine is mainly responsible for exposing the APIs, the methods, method calls, all those things to the outer world. APIs are utilities. And using those utilities, you can program with any of the programming languages. And Spark SQL is mainly used for structured data, can expose many data sets as tables, can be integrated with Hive. Spark streaming enables live streaming data processing, a good alternative to Storm. MLIP, machine learning library being built on top of Spark. It is a replacement for Apache Mahout. Okay, so computation engine, graph computation engine, similar to Apache Giraffe, combines data parallel and graph parallel concepts. So yeah, this is not much we'll be discussing on in our course, like more of like a data scientist or the visualization guys. This is, I can still say, like incubating phase, not much being used, widely using across industry. Okay, and Spark R, I can say like it got integrated in Spark 1.5.1 release only, meaning last 4 or 5 months back only. So you can start, yeah, if you already have any knowledge on R, you can start practicing. You can leverage your R skills on Spark engine. Okay. So now to give the differences or Spark versus Hadoop. Hadoop is more of like a batch oriented, right? So everyone agrees on that. And it takes some minutes to hours to complete sometimes the jobs. So even if you run a Mapreduce job or Hive queries or Pig queries or HBase or these things, HBase will be relatively faster than your Hive or something. But still, when we say the pure Hadoop framework, it's mainly the Mapreduce. So it takes minutes and hours to complete them, whereas your Spark can be completed within a few seconds. Meaning, you will get the real-time response or interactiveness at Spark, whereas it's a batch-oriented Hadoop. And at the same time, we should not treat Spark as a replacement for Hadoop always. Okay. So when you say, yes, now I got upgraded to Spark, I can run everything in Spark with faster speed. So can I remove my the Mapreduce framework or these things? Obviously not. The reason is, let's say if you have a 1 terabytes of files, a 1 TB file is there, and your cluster's RAM capacity itself is a 2 terabytes or 4 terabytes. Let's assume it's just a 2 terabytes your cluster RAM capacity, and you have to process your 1 TB file. Then obviously trying to read that file into RAM memory, your just one single Spark job can eat up all your cluster resources. So there will be some requirements with respect to your business requirements. There will be some scenarios where business users expect real-time responses, and where they can wait for 1 day, 2 days, or a week also. If that is the case, even still you have a Spark when you are really dealing with, I mean, this is just purely based on my real-time experience. I'm recommending this. Okay. So if you really have very huge files, then processing them, and it can be your business users can wait for it, then obviously running it in Hive or running it in Mapreduce is okay to go with. Otherwise, if you use, let's say, 100 GB file or 1 TB file is there, if you try to process that in Spark, you will be holding off all the entire cluster resources without giving any space, any room for any other jobs, other priority jobs in the cluster. Okay. And we'll discuss how does the Hadoop features similar to Spark features and MapReduce features similar to Spark. Like we'll discuss how a mapper phase can be coded in Spark, and how a reducer phase will be in Spark. How does a partition phase or how does distributed cache can be achieved in Spark, and how does counters can be achieved in Spark, and how does partitioning, shuffling, these things will happen in Spark as well. Okay. So all those things will differ them, we'll park it aside for some time. We'll take it up during our Spark architecture sessions. Okay. And it uses in-memory, its speed. You can cache HDFS data in main memory of worker nodes. So Spark analysis can be executed directly on in-memory data. Shuffling can also be done from in-memory. So everything can be almost all. Once it loads the data from your disk into RAM, so everything from there onwards, everything happens in memory. The fault tolerance will be achieved with the help of RDD's concept. We'll discuss those RDD's concept. There is a lot more to discuss on them. Okay. And integration with Hadoop, yes, it can very well integrate with both your Hadoop 1.0 and 2.0 architectures as well. Okay. Next. Yeah. So these are the comparisons between your Hadoop ecosystem tools and Spark ecosystem. Your Hive, whatever the queries that you are running on Hive shells, you can run now in Spark SQL shell. Whatever the algorithms that you are running through the Apache Mapreduce, its equivalent component in Spark ecosystem is Spark MLlib, machine learning library, and Impala, its equivalent component is Spark SQL again. Apache Giraffe is graphics, and Apache Storm is Spark streaming, and Hadoop Mapreduce, it's Spark native programming. Okay, so this is your Hadoop ecosystem tools, and these are your Spark ecosystem tools, if they're equivalent tools.
Shiva?
Yes, Anand.
So quickly, Shiva, why did you compare Hadoop with Spark? Because ultimately Spark will be writing to Hadoop, right? So that comparison did not make sense.
Here, Hadoop meaning the processing of your Hadoop engine, Mapreduce.
Yeah, indirectly, it has to use Hadoop, right? So
that is HDFS.
Or HDFS.
So you are talking about HDFS. My intention behind this Hadoop engine is that Hadoop engine, processing engine is nothing but your Mapreduce, right?
So when we use Spark, it will totally bypass the Mapreduce and whole thing, right? The whatever we have learned, it will only use the HDFS, correct?
Correct.
Oh.
So
it will not get converted into Mapreduce tasks. It will totally bypass that framework.
Oh, and just use the HDFS as storage.
Yep. But we use Yarn framework.
Oh, you do use Yarn framework.
We use Yarn framework. Yeah, you will get. You may get some questions around that right now, but we'll defer those things to Spark architecture. Okay.
Okay, that's fine. Good, thank you.
Okay, so now let's see one simple comparison with Spark native code and Mapreduce code. So the very famous, the big data examples is the word count, right? So just to achieve the word count algorithm in your Mapreduce, we have to write a mapper class and a reducer class and then a driver class and compile them and then prepare a jar and run it on the cluster, right? So for showing you this example, so I have set it up these things on my Cloudera Quick Start VM. So I have this VM. I will guide you through the setup of these VMs and everything from next coming sessions onwards. Okay. So for today's session, just observe the differences, the comparison between Mapreduce job executions and all those things. Anyway, I will guide you through setup of your Quick Start VM or VMware or VirtualBox or these things. If any one of you are already not having. So most of you might be already knowing all these things, but I will still give you a 5 minutes overview on that, okay? Sometime later. So, we need to write a mapper class. So we have a few lines of code here, and we need to write a reducer class for the same thing. Something happened to this. Something wrong with it. Okay. Anyway, that's not an issue. So here is my reducer logic code and word count. this is my reducer, and this is my driver program. Okay, so almost I need to write around 60 to 70 lines of code, and I need to write them, the classes, and compile them and build a jar file and then run it as a Mapreduce job. Okay, let me see. So I already compiled that and prepared a jar file out of it. So I hope everyone is comfortable with that. The Mapreduce jar preparations and all. So that's why I'm not showing you all those things. So I can run this job. Okay. Let me take it. I'll stop my Spark shell. So this is my Hadoop Mapreduce job. So I prepared the jar mr_wc.jar file in my home directory. I'm running that as a word count, and I can see the results here. Yeah, let's see. Let's wait until it gets completed.
Shiva?
Yes, Mamta.
How do we do the logging or debugging here? And do we have the option?
In Mapreduce?
Yeah, I mean, sorry, in the map or in Spark.
Spark, we'll see them. Okay, we'll see how to debug. So there, like you have seen, I have told you some debugging commands in Pig, right? Similarly, you have some debugging commands in even.
I don't remember the debugging things. Okay.
Oh, okay.
Because in the real time, that's more important. Debugging and log, right?
Yes, we will see that. We can do that. There are debugging commands available at each stage of your Spark programming. Okay. So almost like so 12:16 it started, and 12:56 it ended, and so it's, I can say it like all other timings, like before even submitting to the yarn and all these things. So if we take another few seconds, so it's almost like 40 to 45 seconds. Okay, so it ran successfully, and let's see. So this is a simple file here, simple small file processed for word count, simple readme.contents. Let me, sorry, could have taken the path here. Okay. So here you can see the word count of those readme.file and readme.md file. So that I have given. Let's not worry about all these results. I'm just concerned. I just wanted to give you the how concise our code will be and how much faster. So the performance differences and the easiness of development. Okay. So here we had to write 3 programs and compile them and build a jar. And using that jar, I need to run it on the HDFS file and then store the results there and see. I've seen that. Okay. Now, the same functionality, if I have to achieve in Spark, let's not worry about, don't worry about the methods at this moment. Anyway, I will bifurcate all these things and I will explain you all these things one by one. So during your Spark sessions, okay? So before even that, we'll try to complete these things in Scala first. We'll learn the Scala language, then we'll go to that level. So I just have only one line of Spark code. This is just one single line of Spark code. So the same file, the same readme.md file that I gave into the Mapreduce, the same file I'm giving here. Okay. Okay. And let me take this and execute this from my Spark shell. Okay. First, let me get started into the Spark shell. So first of all, you don't have any shell feature for your Mapreduce at all. Okay. So you have to write it as an application, build a jar. That's the only way you can run. So with your Spark, you can run both as a jar. You can write an application and you can build it as a jar and you can copy that jar to any place. You can do that. And before even doing that, if you want to test any of these things from your shell, so you can run them from the shell itself. Okay. So once the shell gets started, here you can see these things. So my current latest Spark release is 1.6.1. Okay. Using Scala version of 2.10.5, and it requires the underlying Java as 1.7. So this is my Spark shell. I can run the same one-liner code. So this is going to read the same HDFS file, readme.md file, and print these results there. Let's see. So just now submitted it. You can see it took just 2 seconds, 2.6 seconds, and it printed the same word count results there. Okay, so I leave these results to be verified for your end. I trust on this. Okay, so how simple your Spark code is. It's just the same one line of code getting completed in 2 seconds. Since this is a very small file, you don't see much number of times is not so big. If you run the same thing, almost like a 1 GB file, or at least take 100 MB file and then run the same Mapreduce program and see the performance differences between how many seconds or minutes your Mapreduce program is taking, and then how many seconds your Spark job is taking. Okay, so I'm giving you these programs here. Since I took only around 1 KB or 2 KB file, you don't see, but still there is a 45 seconds for Mapreduce, just 2 seconds for 2 seconds for your Spark, and around 70 to 80 lines of Mapreduce code in just one line of Spark code.
Shiva, where is this input file? Is in HDFS or in the local
You can
file?
I mean, I'm not giving you the, this current file is in HDFS, readme.md, but I want you to try with on prepare the 100 MB file, text file, upload it into HDFS, run it there, both with the Mapreduce jar and as well as your Spark shell, and let me know your statistics. Okay, I'm giving you this word count program in the today's files, and Spark code is anyway there in the it's one line. You can refer either from the slide, or it can refer from the video as well, or you can type the command. Okay, so don't worry about this explanation of these codes right now. We'll anyway go through these things slowly. Okay. So when I ran it sometime yesterday, so it took almost like 52 seconds of execution time, whereas my Spark took only 2 seconds of time. Okay. And so these are few other points that you can compare. Spark code is very concise, and MR code is high in code base size. Spark has supports for shells execution as well. I mean, executing your Spark commands within a shell, whereas there is no shell support present for Mapreduce. And easy to test Spark applications in shell itself. Need to develop a jar every time and submit on the cluster. Low latency results that we have seen results coming in just 2 seconds, whereas Mapreduce is taking around 50 seconds. And development efforts also will be very less because of rich set of APIs. See, writing one line of code, it will not take more than 1 minute or 2 minutes of time. It's just, you should be strong enough in that skills. That's it. A developer should be strong enough in knowing the APIs. That's it. Your development effort will not take much time. Just one line of code. Whereas in Mapreduce, if you have to write, you need to write 3 components and compile them and build jar and all these things. It at least need an hour time. Yeah.
Shiva?
Yes.
Shiva, but in real life, we don't write Mapreduce code at all, right?
In real life, we don't?
We don't write the Mapreduce code.
Why we don't write? Because we have advanced.
I mean, it is usually handled by either Flume or Impala or Hive. They do that, right?
Yep. So all your SQL, anything that you can achieve through SQL commands, you can achieve it with that, right? So as I told you, some limitations for SQL skills, right? SQL commands, for loops, these things cannot be achieved.
Correct.
So that time you have to go for Mapreduce. The same thing if you go with Spark Native, it will be even more faster. That is what I'm trying to convince here.
And how about the compatibility with the previous versions? Because we had some
previous versions of what?
Whatever, like you get now and then the latest versions, right? It's Spark, whatever.
It's just the API getting changed. I always see there will be always a support for if you are going to new versions, there will be new APIs coming on. Okay, so you can start leveraging them. So they will still be supporting the older version APIs up to some releases. Okay, so this is something like in open source or in any fast changing frameworks, it's the same thing. Like, so what is the same scenario from MR1 to MR2 migration, right?
Yeah, they had so many issues. That's where I'm asking this question.
So it's not, I mean, it's not that much issues or something that we faced ever in Spark releases. It's always that new features will come on and it's you can keep on changing, upgrading. And here maintenance of your code is very easy, right? When you are writing 100 lines of code, if something changed, you need to change 100 lines of code, correct? If it is just one line of code, even if the API changed, just one place you need to change, correct? Relatively, even if it is keep on changing, you keep on releasing the new releases, here maintaining your code in Spark is much less cost effective than Mapreduce, right? What if something new features coming Mapreduce, if you need to change new APIs, if you want to change, right? Meaning you don't say that Mapreduce is already stable, it can solve everything. Meaning if there is no improvement means sometimes it gets older and no one will use it. That's already happening right now. Anything that is improving every release, anything that is changing every release, I mean changing in the sense not improving, I can say, like improving is the right word, it will sustain for longer periods, correct? And we always should be adaptable and leave some space to accept the new improvements. Okay, that's, I don't think that as a, I mean,
no. New improvement is okay when you don't have the compatibility.
Compatibility issues, I mean, version to version, you have to be careful in selecting the underlying Hadoop versions. You don't need to, you'll not really face that much issues, I'm saying, like with my practical skills, experience. Okay? Agree?
Yeah. And
see, compatibility is not something, I mean, that you see with just with Spark or something, right? It's there with every tools, with version compatibility. We have to be careful. There will be, in any tool, there will be new changes coming in, and sometimes they deprecate some methods, and sometimes they add new things. It's the same thing, not something that Spark, you will face a lot of compatibility issues. Okay?
And for this class, what are the things like going on for next sessions?
Mm-hmm.
What all we should have in our systems? And
I will help you. I will slowly explain you what all things you need, and I will show you how to set up them. Okay? But today's session, you don't need anything. I mean, for tomorrow onwards, I will help you in setting up your Scala first on your machines. First, get some knowledge on Scala programming language, and then we'll write all these Spark applications using Scala language. Then I will explain you how to set up the. Tomorrow I will show you how to set up the Cloudera Quick Start VM, and on top of that Scala shells. So once you practice the Scala language, then you can go for Spark, and then I will show you these setups, okay, required setups for others as well.
Is it possible to send any PDFs or something so that like tomorrow for to learn Scala?
Yes, I told you, right? I will send it.
Okay.
I already told you that I will send you Scala.
Yeah.
Okay.
For me, it's 7:30, so I will not.
Yeah. Yeah, I will share it with everyone. Don't worry. Okay.
Thanks, Shiva.
Okay.
Do you have the name in case if I have it from the download? Like
you can programming in Scala. You can download it. Yep, programming in Scala. Okay.
Is there a version or something?
You can download the latest one, 2.10 or something, 2.10 or 2.11. The PDF version I don't remember. The Scala version 2.10 or 2.11 should work with us. And the latest PDF try to download. Okay. If not, I will anyway share it with you. Okay.
Okay. Thanks, Shiva.
Yeah. And we have compared Spark native code with Spark native code with Mapreduce. So let me show you one more comparison with Spark SQL with Hive. Okay. So let me take this time some real-time data. I have some input data related to some retail store. A retail store, I have the retail survey details. There is some trend product IDs, which is int and store IDs, and some CSL IDs and product IDs. I have a sales units and some facts about that retail data. Okay, so some of them are the dimensional keys and some of them are facts are there. I'm just storing this data, this input data for your reference. I kept it. It's around like 500 KB or so. So this data is there in this file itself. Okay, so you'll not get much understanding on that data. Yeah, but that schema is this. That metadata for that file is this. These are those indicators and the facts here. So I created a table in Hive and loaded this data into that Hive table. Okay, so I created a survey details table in Hive and I loaded this input data into this Hive table. And if I run one basic query like aggregation query, so for each product ID, I need sum of sales units. Okay, in one particular store and for one particular week. I have different week IDs in that file and I have different store IDs in that file. But for one particular week and for one particular store, I need sum of sales units for each product ID. This is my requirement. Okay, this is a common business requirement in retail domain. In one particular Megamart store or Walmart store, for 1 week, I need sum of sales units for something. Okay, since this is just some dummy data around that, so I have this select product ID, sum of sales units from survey details table, where period ID is 690 and store ID is this, and group by product ID. So if I run the same query, so I created this table already in Hive. You can maybe for your reference, if you need, I have given you the sample data there and commands to create the Hive table. So I know that there is one guy without practical experience, he just knows the theoretical. So you can use these create table statements and load data in path statements to load that data into Hive and then run the query in Hive. Okay. So I will run this query from my Hive and see how much time and how the results will be like. So underlying in Hive, it's still again running the same number of mappers. And
already loaded the data, right?
Yes, already created the table, already loaded the data into it.
Okay.
Just running the aggregate query, that's it. Okay. So since you guys might be knowing these things, I just gave you sample data file there and commands. You create it on your own in your case. Okay. If you face any issues, let me know. I will help you in that. Okay, it is still running. Let's see how much time it's going to take. Okay, it took around like 62 seconds, right? And it fetched the product IDs for each product ID, sum of sales units. Some of there are five units were sold, and this is 5 units sold, and this was like. And the same thing, if I run it in Spark SQL, And Spark SQL commands also, fortunately, you can run it in the same Spark shell. This is also just one line command. This is one line query, and this is the same one line query. I can run it in Spark SQL.
Query same in both, right? Or is it?
Yes, query same, right? Select product ID, sum of sales unit from.
No, I mean to say syntax.
Syntax is same. Same query. See, same query. See, say select product, sum of sales units from survey details, period ID, this, right? The same query that I'm running in the Spark SQL, right? Same.
Okay, I got it. You have in the codes you're running the same thing.
Yeah. Okay. So now from Spark SQL, it got interacted with your Hive, right? I didn't create any table in Spark Shell, or I didn't create any table in Spark SQL. I'm able to access the same table in Hive and ran that same query, and I got that same aggregate results in just, it's even, for the first time it took relatively faster. Yeah, it took around 10 to 12 seconds. Whereas here, it took almost like 92 seconds. Oh, so it took 92 seconds. Okay. Yeah. So it took 92 seconds, and here it took just 10 to 12 seconds. You can see the performance difference, right? And if I write the same Spark SQL, sometimes, I mean, as I was telling you, Spark SQL is introduced in Spark 1.0 release onwards only. It's not as matured as Spark native, I can say. Okay. And if I write the same Spark native logic, I mean, this is bit lengthy code. I could have made it even more concise, but anyway, let's not, we can do that, of course. But if I can write that purely native instead of SQL skills, okay. So I wrote too many lines of code here. So if I print the same thing, you can see, you will get amazed, like, so it completed in, took 1.9 seconds, almost like 2 seconds, even if you approximate. So this is 92 seconds, and this is in 2 seconds. The Spark native. Spark native ran even more faster than this. Thing is, you can fine tune the way, like the low level control will be there with your Mapreduce than your Hive. Correct? Programming control. And similarly, here the programming control or the optimization control will be more with your Spark native. So that's why we focus more and more on Spark native. And I want everyone, even though you're good at your Spark, your SQL skills, yes, always you can take it granted that you already learned something, okay, even in Spark. But try to focus on Spark native also. Spark native APIs are very, very, very powerful. You can leverage that, okay? Yeah. Okay, Ankita, actually I thought of wrapping up at 9 o'clock itself. Sorry for extending a few more minutes. I'll wrap up. I'm done with the session, okay? You can leave, Ankita, okay? You can refer, I mean, I'm not going to take any more minutes, not more than 3-4 minutes. I'll wrap up, okay? Sorry for delaying it. You can leave for the office if it's getting delayed. Okay.
Hi, Siva, I have a few questions.
Yes, we can discuss. I mean, Ankita was in a rush to leave for office. We can discuss your questions, no problem. Okay. Yeah. So with Spark native, I could even able to run this in 2 seconds. Okay. These are some metrics. So sometime it took 75 seconds only. So just now it took around like 92 seconds in our case. Okay, so let me complete this as well. So to further continue with the session, so the things that I need from your end is 8 GB RAM laptop from your end to practice these hands-on examples, and at least basic idea on big data issues or big data tools and concepts, and basic knowledge on the Linux commands, basic Linux commands. And who are already working in Hadoop, it's understood that you might know the HDFS and Linux commands. Okay, yeah. So now I am open for your questions.
Okay. Okay. My first question is: can we use Spark R for Spark streaming? Yeah,
Spark R for Spark streaming. Yeah. Spark or Logic. Spark streaming we use only
with Scala, right?
Yes, through Scala.
But it's not possible through Spark R.
I may not be right now. I may not make that statement. I can check with people. Okay.
Okay.
Yeah, I never used. I can.
It's fine. It's fine. It's fine. It's fine. I can check with someone and you can let us know. Then the next question is: I'm installing all the ecosystem tools in my Mac. Also, I have installed the Hadoop in my Mac itself instead of using Apache to understand the complexities and the installation requirements, how this is internally aligned with each other. So right now, I installed Hadoop in my Mac, and I installed all other tools separately in my Mac itself instead of installing in Hadoop. Will it make any difference? As of now, everything is working fine.
Your Mac in the sense on Mac operating system itself, or you
Mac
have
laptop.
any
Mac
Linux
laptop.
distribution?
No, Mac laptop.
You don't have a Linux operating system on your Mac.
It is there. It is built in Linux, right? A Mac is developed on Linux or Unix.
Correct.
So
real time, my suggestion is to go with Linux, because you'll always see, 100% of the real time projects will be on your Linux distributions only. Yeah, either on RHEL or CentOS or Ubuntu. These three Linux flavors only. Because there will be slight differences in the commands. To be frank, I never installed on Mac or something. Even if you see all our articles on blog, you can see some of them on Cloudera, some of them on CentOS, some of them on RHEL, some of them are Ubuntu, but I never did on Mac.
Okay, okay, fine.
There will be definitely some difference and some impact also, migration impact.
Okay.
So my suggestion is try to be as close as possible to the real-time environment.
Okay, or I can use Cloudera itself.
Yep. You can download the VM.
Okay.
And I will explain you that VM setup tomorrow, and I will show you the Scala installations and everything.
Okay, okay. Then the next question is, what kind of projects or exercises are we going to see?
So I will share you some Scala project, some Scala. I will be going through each and every concept of Scala and give you some assignments and some hands-on in the session. And at the end of Scala portion, we'll give you some dummy project end-to-end so that it covers all the concepts. And after Spark, I will give you some POCs and I will explain some end-to-end Spark project.
Okay, thank you.
Okay. Yep.
Thank you. Fine, fine. Yep. I'm fine.
Any other questions from anyone else?
Siva.
Yes, Anand.
What language would we need? We need R also, or just the Scala?
Scala. For Spark, you are asking?
Yeah, I was asking what Spark R. When you say Spark R, what exactly?
For Spark R, you need R language.
Actually, Spark R is one of the built-in package. We can use it within R language.
Yep.
That means we can run all sorts of Spark commands within R programming itself.
Correct.
Okay. So, but when we say Spark, it is only on Scala then, right?
Yes.
Correct.
Okay.
Okay.
Thanks. Okay. Yes, Shiva, I probably will call you in 10 minutes for 5 minutes. Is that okay?
Yes, sure, Anand. Yep. Okay.
Yeah, Shiva, myself Purushottam.
Yes, Purushottam.
Yeah, for this Spark, Java is mandatory or only Scala is fine?
Java OOPS concepts, you should know understanding of the OOPS concepts to master Scala skills.
Okay, how long it will take? I mean, how much time it will take to know the Scala?
I will teach you through whatever is needed in Scala. I will take that on my shoulders. Okay, I will teach Scala end-to-end. Only thing is, what is it?
Scala, we are new to Scala, right?
Yes, so, yes. We'll teach you Scala from ABCD. Okay.
Okay.
From ABCD till the level you need it up to Spark. Only thing is, for this, I need a prerequisite from your end is at least any programming language with OOPS concepts knowledge.
And one more thing, but I didn't work on much on Mapreduce. So is it fine for to learn Spark?
That's fine, no issues. Okay. Do you have Java basics?
Yeah. I'm Java guy only.
You are from Java background, right?
Yes. Initial, but not now. Long back, almost 2.
You know what is class, what is inheritance, what is interface, right?
Yeah.
Then I mean, no, don't worry at all. Okay, you will easily grasp Scala and you will easily be able to write everything.
Okay. And one more thing. For in Mapreduce, it will be stored in hard disk, right? Hard drive.
Yes.
And but in the Scala, Spark will be stored in memory, right?
Correct.
In the hard drive, it will store large amount of data, but in Scala, it will be stored in memory. It will be less data only. It will be stored, right?
That's why we make use of the entire cluster RAM memory, right? So when you say 20 node cluster, okay?
Okay.
And each node you have 256 GB RAM, meaning so every 4 nodes will become 1 TB, correct?
Yeah.
So 20 node means 5 TB. So 5 TB is a huge RAM memory, correct?
Yes, correct.
You will not find any one single file having 5 TB. In real time, I can guarantee that. You'll see 100 GB files max or maximum of up to 1 TB.
And my doubt is in Spark, just I know a little bit, means just to go through the blogs and all.
Mm-hmm.
If you're running the Spark, you can give the, while run the application, you will give the in some memory. You can specify the memory, right?
Yes, you can specify the memory parameters as well. Correct.
Yeah, but it's very less. Like I can give 20 MB or something like that. I mean, it will store less data only. But if you are fetching the data, means that particular 20 MB data only it will be fetching, right? The entire data won't be fetching. So
correct. It will be fetching the chunks. Okay, 20 MB at a time.
But
that is a huge topic, Purushottam. Let's not worry about that at this moment. We'll discuss not just that property. There are so many configuration parameters. We'll go through each and every one of them. Okay.
For practice purpose, you are giving any cluster like.
I will be helping you in setting up this VM and setting up the Spark on your machines.
Okay.
That is enough. And I will show you the real-time Spark cluster from my machine on a 20 node cluster or something. I will show you how does the real-time configurations look like and how does the real-time Spark shells or it's not much different. I mean, the people who attended my Hadoop trainings, they know that I have shown them the real-time clusters and I have made them practice in the VMs during their training, and at the end, I have shown them the real-time cluster server. There is not much migration efforts. Okay, there will be very few minor changes, but still I will show you the real-time cluster, and until then you can practice on your VMs. Does that make sense, Purushottam? Hello? Okay, I think I lost your audio, Purushottam. Okay. Any other questions? Gopi, Kalpana, Madhavi, Mamta. I think someone got dropped out. Ankit. Okay. Kalpana, yes. Do you have any question?
Yeah, as of now, I don't have any questions. I mean, I want to talk to you personally. Please let me know your free time.
Yes, you can call me in another 15-20 minutes. You know my number, right?
Yeah.
Okay.
Thank you.
For your reference, I think everyone knows my number, but still, let me post it on the chat box with everyone. You can note down my number, +91 9704231 yeah, and leave me your WhatsApp mobile numbers and your active Gmail IDs before logging out of the session, because I will add you to the active WhatsApp group. You can post all your common questions, anything to there, and I will be actively answering your questions in that. Okay.
Shiva, this is Madhavi. I'll call you back as well.
Yes, sure, Madhavi. Call me in another 30 minutes then. Okay. First, I will talk to Anand, Kalpana, and then you can call me. Okay.
All right. Thank you.
Yep.
Shiva, are you recording the session or can I access from anywhere?
Yes. Every session will get recorded. And after the session, this recording will get uploaded into Google Drive.
Mm-hmm.
And from there, I will give you read permissions to it. Okay.
Okay. Thank you.
Yep. Yeah. Anything else from anyone? If not, we can wrap up the session for today. Okay. So you can call me immediately, Anand. Okay. So if anyone is missing posting their email ID and WhatsApp numbers, please do that. Either you can send it privately to me, and it can be shared with across everyone. Okay. Yeah. Thank you, guys. Thank you very much for joining the first session. Okay.
Thank you.
Thank you.